Port Swigger Academy. If you're not familiar with this site, it's a very good companion to Burp Sweep the tool. If you don't know what Burp Sweep the tool is, you're gonna have to actually Google that yourself, because it's a proxy tool used for bug bounty. So you're gonna have to Google that yourself. So what I'm gonna do is that I'm gonna go through the labs that they have with the Burp Sweep, and then we're gonna try to learn a lot about the bugs that you learn through here, right? If I'm not mistaken, a lot of people recommend Port Swigger Academy. So you're gonna be required to create an account, as you can see, and then then from there you're allowed to use the Academy site, which will explain in detail what the bugs are and how you could solve them, pretty much, right? So right now I'm going through the API version of stuff. So APIs are application processing interface. So at the end here, normally there will be an API, and the API will give you some sort of functionality that's asking that. So an API, in other words, would be like, it's like the browser is asking, or the application or the domain is asking some server at the backside, hey, let me get some sort of functionality, right? Whether it could be the web camera, it could be anything, right? So that's pretty much what APIs are. It's access to code that does something. So here, as you can see, is lab exploiting an API endpoint using documentation. To solve the lab, find the exposed API documentation and delete Carlos. You can log into your own account using the following credentials: Wiener and then Peter, right? To solve this lab, you'll need to know what an API documentation is, how an API documentation may be useful to an attacker, how to discover API documentation. These points are covered in an API Testing Academy. So let's try that for now. Actually, let me do this. Let me open another tab so we don't get lost. Alright, so let's get an overview of what and how we can do these three things that you can see here. Let me see if I can maybe find it. Yeah, it's this one right here. So as you can see, it's a whole progression of things that will be very useful. So when we try to do bug bounty, which I'll eventually want to get into and show you guys, this Port Swigger site is very helpful. So I'm actually going to focus on this a lot to really try to sharpen my skills at bug bounty, because it's very important. Or web application testing, as it's called, right? So let's go back here and learn a little something. API, application programming interfaces, enable software systems and applications to communicate and share data. API testing is important as vulnerabilities and APIs may undermine core aspects of a website's confidentiality, integrity, and availability. All dynamic websites are compromised of APIs, so classic web vulnerabilities like SQL injection could be classed as API testing. And this topic will teach you how to test APIs that aren't fully used by the website front end, with a focus on RESTful and JSON APIs. We'll teach you how to test for server-side parameter pollution vulnerabilities that may impact internal APIs. To illustrate the overlap between API testing and general web testing, we created a mapping between our existing topics. OWASP API Security Top 2023. Let's give that a quick look. Let's see what we find. Because at the end of the day, all that stuff is connected. Alright. Web Security Academy alignment with the OWASP Top 10 API vulnerabilities. The OWASP Foundation periodically publishes a list of critical API-specific security risks. Although some of these risks have a different name in context of APIs, many of them align with our existing Web Security Academy topics. The table below specifies which Web Security Academy topics are relevant to the OWASP Top 10 API vulnerabilities. So as you can see here to the left, right, risk, broken object level authorization, access control vulnerabilities, and privilege escalation. broken authentication vulnerabilities, AAuth 2.0 authentication vulnerabilities, JWT attacks, JSON Web Tokens attacks, broken object proprietary level authorization, mass assignment vulnerabilities, unrestricted source consumption, race conditions, filed upload vulnerabilities. Let me click on this one. I've heard of this one before, race conditions. I'm curious to see what this is. Alright, so let's see. Race conditions. Race conditions are a common type of vulnerability closely related to business logic flaws. They occur when websites process requests concurrently without adequate safeguards. This could lead to multiple distinct threads interacting with the same data at the same time, resulting in a collision that causes unintended behavior in the application. A race condition attack uses carefully timed requests to cause intentional collisions and exploit this unintended behavior for malicious purposes. So it sounds like whatever race condition, I guess you get to you're telling the computer, like you're getting, it's almost like a desync attack where like you're trying to get it to do something, like you get its timing off, and then maybe do another request where you see if maybe that it accepts that one. I know it's all this shit is pretty fucking complicated. I'm not gonna lie, it's not easy. So I'm gonna read it one more time so I kind of understand it. So or here, let's see. G and J shop, post, gift, redeem, HTTP2, host, ginandjuice.shop, code, and then it's throwing that in. So gifts, cards, applied, gift card, applied, gift card, applied, invalid gift card, redeeming gift in 5 milliseconds. The period of time which is a collision is possible known as the race window. This could be the fraction of a second in two interactions with the database. For example, like other logic flaws, the impact of race condition is heavily dependent on the application and the specific functionality in which it occurs. In this section, you'll learn how to identify and exploit different types of race conditions. We'll teach you how Burp Suite's built-in tools can help you overcome the challenge of performing classic attacks, plus a tried and tested methodology that enables you to detect novel classes of race conditions in hidden multi-step processes. These go far beyond the limit overruns that you may be familiar with. Portswigger research. As usual, we provided a number of deliberate vulnerable labs that can be used to practice of what you learned safely against the realistic targets. Many of these are based on original Portswigger research, first presented at Black Hat 2023. For more details, check out the accompanying white paper, Smash the State Machine, the True Potential of Web Race Conditions. Limit overrun conditions. These well-known types of rare conditions are able to exceed some kind of limit imposed by the business logic of the application. For example, consider the online store that lets you enter a promotional code during checkout to get a one-time discount on your order. To apply this discount, the application may perform the following high-level steps. Check that you haven't already used the code. Apply the discount to the order total. Update the record in the database to reflect that you've now used this code. If you later attempt to reuse this code, the initial checks performed at the start of the process should prevent you from doing this, right? Submit discount codes is the first request. Code already used, false. Apply discount. Set code already used, true. And then request 2. Submit discount code. Code already used, true. So I guess this is where I recognize that it's been changed on the second request. Rejected invalid code. Now consider what would happen if a user has never applied this discount code before. Try to apply it twice at almost exactly the same time. Request, submit discount code. So hold on. Request 1, request. I'm trying to see where the difference is. So it looks like it's trying to send two of them, two requests at the same time, but I don't really see the difference. So this is the original one, time, and this is the race window, but the code itself is the same. Set code already used to true, set code already used to true. As you can see, the application transitions to a temporary substate. That is a state that it enters and then exits before request process is complete. In which the case, the substate begins when the server starts processing the first request and ends when it updates the database to indicate that you've already used this code. This introduces a small race window which you can repeatedly claim the disk on as many times as you like. There are many variations of this kind of attack: redeeming a gift card multiple times, rating a product multiple times, withdrawing or transferring cash in excess of your account balance, reusing a single CAPTCHA solution, bypassing an anti-brute force rate limit. Limit overruns a subtype of so-called time of check to use Takutu flaws and later in this topic. We'll look at the same. Hold on. I want to do something real quick, guys. Gemini. Alright. Explain race conditions to a beginner bug bounty hunter like me. One thing that I like doing when it comes to learning stuff is getting multiple perspectives on a thing, because like Burp Sweep is actually doing a very good job of explaining it, but the way that I learn stuff is that I like Googling stuff. We'll actually look at, after reading this, we'll actually go into, maybe Medium to see if somebody got a bug bounty based off race conditions, to kind of understand and have a big picture of what the bug is, right? And what is vulnerable, because again, there's so much technology stacks out there. Is a Windows 7 server more vulnerable? Is a Windows 10 server more vulnerable? Is an Apache Linux server more vulnerable? Is something running, Flask more vulnerable? Is something running, etc., right? So you have to get an overall big picture of what you're trying to exploit, right? Because every technology acts the same, every computer acts differently, and again, there's many variables to that. Again, maybe the server's running, 4 gigabytes of memory, it's very basic, etc., where, big companies don't go basic. They'll have 32 gigabytes of memory, etc., and they have a bigger, they got bigger budgets, better, security, etc. So anyway, let's see this. Alright, partner, listen up. You're out there tracking down your bounties, right? You got thrusty sidekick, maybe a fancy trekking device, a whole lot of hustle. Now imagine this. You're two different ways to snag your target. Let's call them Route A and Route B. Both routes lead to the same guy. If you get him, you get paid. Simple, right? Now a race condition is like when you and your rival bounty hunter Vicious Vig both get a tip on the same target at the same time. You both take off full throttle trying to be the first one to bag him. Here's where it gets tricky. When you think you're gonna win, your program thinks it has control. You might be faster on your feet, or you have better shortcut. You're confident you'll reach the target first and get the reward. Vicious Vic thinks he's gonna win. Another part of the program thinks he has control. But Vicious Vic has souped up hover bike, and he's just as determined. He's also trying to get there first. The target, the shared resources. The target is the shared resource. Only one of you can capture him and get the bounty. The unexpected outcome, the race condition. Now the problem isn't just who gets there first. The problem is what happens is your actions or Vic's actions interfere with other in an unpredictable way. Let's use an example. Imagine the bounty is held in a secure vault. This is a little too much. Should have just been a little bit more technical and straightforward. Let me see the unexpected outcome. So now the problem isn't just who gets there first. The problem is what happens with your actions or Vic actions interfere with each other in an unpredictable way. Let's use an example. Imagine the bounty is held in a secure vault and the only one person can enter at a time. You get to the vault, you start punching the code, but as soon as you hit the last digit, Vicious Vic shoves you aside. He then quickly inputs his code. Now, who gets in? It's a mess. Maybe your code partially went through, but then Vic's finished it and he gets credit. This is like getting data corrupted or unexpected value stored. Maybe the vault locks up entirely because the two codes were entered at once. This is like a system crashing or getting into an invalid state. Maybe by some fluke you both get in and the bounty is split, which is definitely not what you wanted. This is less common but still possible, an unexpected outcome. In computer terms, a race conditions happens when you have multiple operations like Vic and trying to access and change the same piece of data or resource, the bounty target vault. The final depends on the... Let me see, why is there a problem? I want this thing to explain this shit better. Okay, I'm liking what I'm seeing now. Alright, bounty hunter. This is the cowboy mad for us to get down to the gritty. Silicon and cold reality of race conditions. Think of it less like a Wild Wild West shootout and more like a highly complex, multi-threaded heist where timing is everything. And a single millisecond can screw up the whole operation. In technical terms, a race condition occurs with multiple threads or processes. Think of them as independent agents or lines of action within a program, access and attempt to modify the same shared resource. A piece of data, e-file, a network connection, a database record concurrently. The final outcome of the operations depends on the unpredictable scheduling and interleaving of these threads by the operating system or processor. If the program's correctness relies on the specific sequence of operations, and that sequence isn't enforced, a race condition can lead to logical errors, data corruption, crashes, or security vulnerabilities. Let's break down the components. Threads. These are independent paths of execution. Threads typically run within the same process and share the same memory space. This makes them very efficient for communicating but also susceptible to race conditions. Let me ask you this question. Can you make me a picture describing all of this or a illustration? They're usually corrected. Let's see what it says. So let me go up. Looks a little we're getting a little complicated, but that's what we want to kind of understand. Processes are more isolated. They have their own memory space, while they can still share resources like files or network sockets. Sharing data directly within memory is less common and usually requires explicit inter-process communication mechanisms. Shared resources. This is anything that multiple threads or processes can access and modify. Examples: global variables, accessible from anywhere in the program, Heap allocation data structures, data created dynamically and pointed by multiple threads. Files, writing to or reading from the same file. Database records, multiple users trying to update the same row. Hardware devices, multiple parts of a driver, trying to control the same hardware. Concurrency, this is the key. It means the operations are happening at the same time. This can be true parallelism on a multiple core processor or interleaved execution on a single core processor. The OS rapidly switches between threads, giving the illusion of simultaneous execution. The classic example, the increment operator. Imagine you have a variable counter initialized to 0. Two threads want to increment it by 1. Thread 1 reads counter and the value is 0. Thread 2 reads counter and the value is 0. Thread adds 1 to its local copy, the result is 1. Thread 2 adds 1 to its local copy, result is 1. Thread 1 writes its local copy back to counter, the value is 1. Thread 2 writes its local copy to counter, value is 1. Expect result should be 2. Actually, the result is 1. This happens because operation counter equals counter plus 1 isn't atomic and divisible. It's typically broken down into 3 machine level instructions. Load, increment, store. If the threads interleave their instructions in an unlucky way, you'll get... Fuck, man. How is this tied to bug bounty? Here's an illustration to help you visualize a condition. I need a more simpler explanation of race conditions and how to find them on web application. Alright, let's see this bad boy, what this about. So, race condition, right? Let's see if I even got it right. So, shared resource. So, there's a thread. Shared resource, no, thread. This isn't really explaining anything, in my opinion. So, the shared resource, you got thread here, and then you got thread here. It's obviously communicating some sort of data. But I think I should have been more specific on what I wanted. Alright, let's simplify this even further. For a web app context, forget the multi-core processing threads for a second. The race condition for web apps, the last cookie wins problem. Imagine your web application is a busy bakery. The cookie jar, shared resources, this is a crucial part of your web app that everyone's trying to update or use. Like a user's account balance, an inventory count for a product or a special discount code. And then you got customers, user requests. These are all the users hitting your website at the same time, sending requests to your server. And then you got the bakers, server process threads. Your web servers has many bakers, processor threads working simultaneously to handle all these customer requests. Each baker can pick up on a request and start working on it. Now, a race condition happens when 2 or more customers try to get the same last cookie from the jar at the same exact time. 2 or more bakers simultaneously react to that cookie. The order in which they grab it, check if it's there, mark it as taken, and unpredictable. The last item in stock, let's say you have an online store and there's only one limited edition widget left in stock. Customer A clicks on buy now. Customer B clicks on buy now at literally at the same millisecond. Here's how a race condition can play out without proper handling. Reads widget 1 in stock. Check is 1 greater than 0, yes of course. Decides customer A can buy it. Pause for a tiny moment. Maybe waiting for a database response for the operation. Baker 2 handling customer B's request. Reads widget 1 is installed because Baker 1 hasn't updated it yet. Checks is 1 obviously greater than 0, yes. Decides continues without pause. Subtracts 1 from stock. Widget is in stock 0. Completes customer B's order. Customer 1 resumes for customer A. subtracts from customer stock, widget in stock, completes customer A's order. Result, you just sold 2 widgets when you only had 1. Both customers got a success message, but you have an inventory mismatch. Okay, so now this is all fucking making sense. And again, this is why you gotta keep fucking reading and reading and reading and reading. So a race condition bug pretty much is, and it has to be, I guess, 2 requests are talking to a fucking server. And let's just, I'll give you a good example. Let's just say you own a shoe store, right? An online shoe store. And you got these Jordan 11s, right? Available, and you only have 1 in stock. So a race condition vulnerability is that if 2 people on that exact millisecond buy your shoes, the computer says, okay, yes, like, we have this available, compared to if the person buys it even a millisecond off, right, or earlier, the inventory will just say, no, sorry, we're out of the shoe. The person A bought it first. So the customer A and B at the same time sent the request, and then the server processed at both the requests at the exact same time, thinking that the shoes are available. So both these customers got a success. Yeah, thanks for purchasing. But in reality, there's only 1 pair of shoe, and the other customer wasn't notified of oh, sorry, we're out, right? So if that makes any sense. So alright guys, hold on, just give me a second. Alright, so I guess I understand what that is now. I guess we have a good idea of what race condition is. So that's a pretty dope little bug, I guess you would say. But again, as usual, you know, that's what again, as usual, you get lost in like a rabbit hole. So if you find a bug, which usually leads to another bug, so a race condition is pretty much a logic flaw, it sounds like, you know what I mean? It would be more based on logic, a logic flaw than anything else. So let's go back to our API testing. So API application, I believe, if I'm not mistaken, we already kind of went through this. But let's go over it again. Alright, so API, application programming interfaces, enable software systems and applications to communicate and share data. API testing is important as vulnerabilities and APIs may undermine core aspects of a website's confidentiality, integrity, and availability. All dynamic websites are composed of APIs. So classic web vulnerabilities like SQL injection could be classed as API testing. In this topic, we'll teach you how to test APIs that aren't fully used by websites front end, with the focus on RESTful and APIs. We'll teach you how to test for server-side parameter pollution vulnerabilities that may impact APIs. Before we do that, let's learn a little bit more about this using Gemini. Oh no! Alright. Teach me more and in depth about this class of bug. I am currently doing a lab on port swiggers. I Academy. Please be in depth. I would appreciate that. Server-side parameter pollution is a fascinating... Hold on, I gotta make sure the music's playing. Server-side parameter pollution is a fascinating, often overlooked class of web security vulnerability. It occurs when a web application embeds user-supplied input into a server-side request to an internal API or another internal component without properly encoding or sanitizing that input. This means an attacker can manipulate or inject parameters into these internal requests, leading to unexpected behavior. Let's break down server-side parameter pollution. Again, let's read it one more time, because server-side parameter pollution is a fascinating and often overlooked class of web security vulnerabilities. It occurs when a web application embeds user-supplied input into a... You know what? Hold on, guys. I'm gonna have to. I'm gonna shut down my my Burp suite. I have it running because we're actually learning to feel like more of the bugs than actually running the tool. So I'm gonna shut that down. It's sucking up battery. Server-side parameter pollution is a fascinating, often overlooked class of web security vulnerabilities. It occurs when a web application embeds user-supplied input. Into a server-side request to an internal API or another internal component without properly encoding or sanitizing that input. That means an attacker can manipulate or inject parameters into these internal requests, leading to the unexpected behavior. Let's break down SSPP in depth. What is a server-side parameter pollution? Imagine a typical web application where your browser interacts with the front-end server, and that front-end server in turn talks to various internal APJs, right? Which I don't even know what the heck that is. Or databases to fulfill your request. SSP happens when user input from the browser or a query parameter, a form field, or a header is directly used to construct a request sent from the front-end server to a back-end system. It is this embedding isn't done carefully, an attacker can pollute the parameter of that internal request. The core of the issue lies in how different web technology and server-side components handle multiple instances of the same parameter name. For example, if you send a request like param value and then param value 2, different systems might process only the first instance, value 1, and process only the last instance, value 2. Concurrently, the values, value 1 and 2, or value 1 or value 2, create an array, value 1 or value 2. The inconsistency, especially when combined with a lack of proper encoding, is what attackers exploit. Key characteristics of SSPP and internal interaction. The vulnerability typically involves the front-end application making a request of internal APIs that is not directly exposed to the internet. User input embedding user control data is directly inserted into the parameters of this internal request. Insufficient encoding. Let me see, hold on. Can you give me a illustration of this bug? How it's exploited? Ah, fuck. Aquí, doña, yo soy tan pendejo que aquí son los metros, ¿verdad que sí? It's metros. Yo trabajo con pulgas, inches. Yeah. That's funny. Alright, let's see what it came up with right here real quick. Attacker, request, server, line cable. This is the thing that AI doesn't usually get correct. As you can see here, right? Like, none of this even makes sense. Like here, WACHUSHA's data override the intent, query parameter. Obviously, we got code here, but it doesn't even make any sense. Lister, PI, molecules, corroding. And then you got a function. Query parameter. Man, none of this makes sense. Yeah, of course, redefine. Redefine the picture to make more sense. The code is off and it doesn't make much sense. Uh-oh. More of the same. What doesn't make any sense. This isn't really even a real Euro. People say that AI is coming for you. One thing I'll say about AI is that it does a hell of a job of explaining stuff, and I have a feeling that the stuff that it's explaining to you is stuff that's already been either uploaded to the database of the AI system. Like some researcher who was very brilliant did a whole maybe 70-page explanation of a bug and how he broke in, what the bug is, where the bug is in the code, etc., etc. And it just shows you a version of that shit, right? Because when I ask AI to do something, it never does something right. Look at this shit. Like, how am I can't use this. What the fuck is this? None of this makes any sense. You know what I mean? Like, AI is coming for you what? Nah, humans. Until I see an AI that I'm just fucking mind blown, where I could see this AI say, okay, buddy, you want a server-side motherfucking look, I didn't even spell parameter right. You want to server-side fucking pollution? You want to find those motherfuckers? You want to see AI work hard and find it? All right, buddy, I got you. And then it just starts running, scanning the whole fucking domain, subdomains, and it starts saying, okay, you know what, bro? I created this program right here for you. Run this shit. This is going to start scanning for possible server-side parameter pollution. Boom, 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 bang, bang. And they can do that thing flawlessly. Then I'll believe in fucking AI taking motherfuckers' jobs. Till then, this shit is just crap, bro. You know what I mean? Like, it does a good explanation. Like, it does certain things right, but it just doesn't do others right. You know what I mean? That makes sense. So, I don't know what let me go through this again. Server-side parameter, didn't even spell it right. Pollution, didn't even spell pollution right either. And it didn't even spell this right either. S server-side parameter pollution should be 2 P's. This isn't even a fucking euro. HTTPL, it's not that. It should be HTTPS, if anything, and it doesn't even repeat twice. It should be HTTPS / I did get that right, and then there will be a domain www.google.com, and then / backslash, and then the parameters, which this will be right as well. It will be this. It could be that, and then here on the bottom it's showing code Malrubis. I don't even know what that even means. Again, in the back end code could be anything. I don't know, but I don't know what Malrubis. It doesn't make any sense. And then name admin, user admin, name admin, user admin. Like that shit don't make any sense. None of this makes any sense. Name admin, and it even has a curly bracket. A bracket. I didn't even do the bracket right. It would have to have another bracket somewhere around here. Let me see. Nope, nope, and nope. Alright guys, so my laptop is dying. So I want you guys to do this. I want this to be your homework. I want you guys to also try to learn as much as you can about server-side parameter pollutions. If anything, let me do this. Duck, go, server side parameter pollution write-ups. Again, whoop. Let's see if we find any bugs related to server side pollutions. But here infosec write-ups, right? Parameter pollutions. What do you mean? What the heck? And I'm exposing myself pretty much. Oh, I don't like that, but whatever. There we go. Sometimes, our internet acts weird and we need a little help by our folks, at the VPN providers. So, let's see. Parameter pollution. How to hunt bugs. Hopefully I don't gotta log into all you dirty MFers. So it looks like I had to fucking log in to read this shit. Let me see. Let's see. Maybe we can read something here. Hopefully we don't gotta log in and stuff like that. Alright, this one's a little cooler. Exploiting server-side parameter pollution in REST API. To start API testing, you first need to find out as much information about the API as possible to discover its attack surface. APIs are usually documented so the developers know how to use and integrate them. That's actually another piece that we should add to our homework. How to read and use API documentation for, should I use bug bounty or for web? Yeah, bug bounty. Go in depth and explain everything. Alright, so when hunting for bugs, especially in context of bug bounty programs, they pay out missions an invaluable resource. It's like a treasure map that points to potential vulnerabilities, often in places that less diligent researchers might overlook. Understand, oh, what the... Oh, sorry about that. I guess I'm watching something. So it's like a treasure map that points to potential vulnerabilities. Often. So the points map, the purpose of API documentation, but bound understand application logic, a detailed blueprint of how applications, various components interact. This helps you grasp the intended flow of data, business logic, and the relationships. And you see discovering endpoints. It is a list of API endpoints that get their methods. Let me see. Let me ask you, what would be a... Oh, shit. What would be a good start? No, what would be a good API to start off with and most commonly used in web applications? Let me see. That's an answer to the question. As you're starting off, the right API can make your learning journey smooth and engaging. When it comes to web applications, some APIs are far more commonly used and offer a great entry point for understanding how they work and eventually how to find vulnerabilities. Here's a breakdown of good APIs to start with. Focus on common usage and user learning for bug bounty purposes. The best APIs to start with are bug bounty and why. For someone starting with API testing and bug bounty, the goal is to pick an API that is publicly accessible, no need for special permissions and complex signups, well documented, clear instructions on how to use it, relatively simple, not to mention complex business logic flow initially. Commonly used patterns reflect how many real-world APIs functions, fake or mock APIs for learning. Before jumping into real-world APIs, it's often beneficial to start with API significant design for testing learning. JSON placeholder. What is a free online REST API that can be used whenever it needs fake data provides? What is a... Alright guys, as you can see here, right? I mean, everything is just a fucking connected shit show, right? So if this is how computers are always gonna be, in my point of view. If you learn something about one fucking bug, one class of bug, that shit's gonna be connected to another one, and then you're gonna have to learn the makeup of whatever that bug is, and you're gonna have to read the API documentation, and this BS and that BS, etc., etc. So again, guys, so what we went through again is that we originally started with the API testing, as you can see here, through the Port Swigger Academy. And I actually had a Burp Suite running. I'm like, okay, I'm ready to test this bad boy up on our lab, but you have to understand the bug that you're looking at to really truly see if you can chain bugs together, because you don't want to be that guy, you know, like for example, let's just say your car stops in the middle of the road and you're looking, you know, you open up the hood and you look at the engine, you're like, oh, what the heck is going on, right? You don't understand how an engine works. You don't understand the makeup. You don't understand what makes it run, right? You don't know if maybe the battery is bad. You don't know if the alternator is bad. You don't know if the gas ran out. You don't know if you don't know if some sort of electrical issue happened. You don't know if the belt ripped off. You don't know any. All these issues, you know what I mean, can be the cause of why an engine doesn't work properly and why your car doesn't run. So you're better off understanding how an engine all is put together. So it's essentially the same thing with bug bounties and finding bugs. You kind of have to have an understanding of how it all kind of fits together, and I'm here to learn that journey with you guys, and I'm definitely going to do that. And again, I start off with API testing, right? And API testing, something tells you that it's going to take me a good 1 week maybe of learning. So in my opinion, that's what I'm going to teach you guys. We're going to learn bugs together, and that's what I plan on doing, alright? So thanks for watching, and see you guys tomorrow, hopefully. And we'll continue doing the bug bounty.